Good morning and welcome to class today. Today we are learning factorization of quadratic expressions. In the course of this lesson, we seek to understand what quadratic expressions mean. We are going to learn how to separate the middle term in a quadratic expression. We are going to learn the steps to factorizing quadratic expressions, and we are going to solve problems relating to factorizing of quadratic expressions. So, let's begin. What is a quadratic expression, or what does it mean? In mathematics, a quadratic expression simply means an expression in the form ax squared plus bx plus c. In other words, we have a single variable. This is not an expression in two variables. We don't have x and y. We only have a single variable x. A is the coefficient of x squared, b is the coefficient of x, and c is a constant. And the highest power of x is 2. We don't have x cubed, and we must have a term in x squared. This is an example of a quadratic expression. X squared plus 2x minus 4. This is a quadratic expression. Now, how do we factorize quadratic expressions? The simple answer is factorization by grouping, which we learned in our previous class. The link will be in the description of this video. However, in order to factorize by expression, we know that we need at least 4 terms in this form, AC plus AD plus BC plus BD, where there is no single common factor, but for each 2, there is a common factor. In this case, we only have 3 terms, so it's not possible to use factorization by grouping when the expression still looks this way. However, we can still use factorization by grouping if we separate this middle term, this b of x, into 2 terms, which will then make this 4. But it is not every term that we separate this into that will be able to apply factorization by grouping to. In order to choose the correct term, there are certain things we need to think about. First of all, those 2 terms must sum up to give us b of x. Otherwise, we'll be having a different expression and not the same expression that we mean to factorize. And the 2 of them must multiply to give us the product of the coefficient of x squared a and the constant c. Otherwise, we will not be able to apply factorization by grouping to that expression. Now, these are the steps to factorizing an algebraic expression. The first step will be to multiply the constant and the coefficient of x squared. That's our a and c. And then we list out all the pairs of factors for a times c. After that, we have to sum up all the pairs of factors to identify the one that sums up to b. When we find that pair which sums up to b, we take those pairs to replace b in the original expression, and then we can apply factorization by grouping. These are some hints on some hints to help us separate our middle term or find out the signs of our middle term. When we have the 2 signs in the expression positive, then both middle terms will be positive. If the first sign is negative and the second is positive, then both middle terms will be negative. If the first sign is positive but the second is negative, that means both middle terms will have different signs, and the larger one will be positive while the smaller one will be negative. But if both signs are negative, that means both middle terms will have different signs. The larger one will be negative and the smaller one positive. Now let's solve an example. Consider this: 3x squared plus 7x minus 6. How do we solve this? What will be our first step? In the previous slide, the first step will be to multiply the coefficient of x squared and the constant, that is 3 and minus 6. So we do that. 3 times minus 6 will give us what? Minus 18. After getting minus 18, what do we do next? We have to find all the factors of minus 18. Every number that multiplies, every whole number that multiplies to give us minus 18, we'll identify them and pair them up. So these are the numbers that will multiply to give us minus 18. We have minus 1 and 18, 1 and minus 18, minus 2 and 9, 2 and minus 9, minus 3 and 6, 3 and minus 6. These pairs of number, each of them multiplies to give us minus 18. So one of them will be the set we'll replace our middle number 7 with. What pair? We need the pair that sums up. When we add both of them, we get 7. And so we are going to add each of them. Minus 1 plus 18 will give us 17. 1 plus minus 18 will give us minus 17. Minus 2 plus 9 will give us 7, which is the number we are searching for. Let's see if there's any one that gives us this. 2 and minus 9 will give us minus 7, which is also wrong. 3 minus 3 and 6 gives us 3, and 3 and minus 6. 3 plus minus 6 gives us minus 3. So we can see that our middle term is going to be minus 2x plus 9, because you can add both of them to get 7. So coming back to the question, 3x squared plus 7x minus 6. The middle term 7 will be replaced with minus 2 and 9. So we are going to have 3x squared minus 2x plus 9x minus 6. This is what we are now going to factorize by grouping. So applying factorization by grouping, we have 3x squared and minus 2 grouped into this bracket, and here we have 9x plus 6 into this bracket. What's our common term here? We have x here and x here. So we factor x out and we'll be left with 3x minus 2. And here we can factor out 3 to get 3x minus 2 as well. So 3x minus 2, both common factors will lead us to factorizing this expression into 3x minus 2 multiplying what is left, 3 plus x plus minus 3. So this expression has now been factorized fully by grouping. And this is the way we deal with quadratic expressions. This is the way we factorize quadratic expressions. I hope you were able to learn something today. Here are some practice exercises. We have 3x squared minus 7x plus 4. We have 2x squared minus x minus 6. X squared plus 7 plus 6. And x squared plus 3 minus 10. Solve these examples and post your answer to our page in Google Classroom. I'll be evaluating you and grading you. Take your time, study this video, watch it over again, and ask any questions on whatever you don't understand.